Hello, everyone. We are going to be looking at gas laws today. You will notice here that we have our question already written out for us. A sample of nitrogen has a volume of 50 liters at a pressure of 760 millimeters of mercury. What is the volume of a gas at a pressure of 1500 millimeters of mercury if there is no change in temperature? I'm going to take this time to break down a couple of concepts. As you can see, it is not labeled what gas law you would need to use to solve this problem, and that was done on purpose. Certain pieces of information are given in the problem, and it is up to the interpreter to know what they're being asked. So, in order to break this down, let's take a couple of notes, and then I'll be able to explain how you know what you're working with. So it says I have a volume. So I know I'm dealing with V. Okay? We have 50 liters. At a pressure of 760 millimeters of mercury. What is the volume of a gas at a pressure of 1500 millimeters of mercury? So we're looking for the V2 if there was a change where P2 is now 1500 millimeters of mercury. Now you may be asking yourself, I don't know what formula I need. I have three pieces of information. One is missing. What do I do? Well, let's look at it like this. We are all in nursing school. So once again, one of our handy dandy light bulb moments. We are nursing students. Nursing students learn how to take blood pressure. We do. This problem has given me pressure. And if pressure is given in the problem, I am solving a Boyle's law problem. Boyle's law has a relationship between volume and pressure, but no change in temperature. Temperature is not a factor in Boyle's law because it does not change. The only factors that change are at some point in time a volume or a pressure. So always remember Boyle's is BP. Boyle's gives us pressure. So we're nursing students, we take blood pressures. Boyle's BP is the problems that work with pressure. So our base formula for Boyle's law is going to be P1 V1 equals P2 V2. Now we know that we're solving for V2, so we would need the conjugate or derivative of this formula. So V2 is equal to P1 V1 over P2. And this is provided in your formula sheet, or it's just the case of isolating V2, which was to divide both sides by P2. Okay? So now we get to do the part of what they call plug and chug. So we're going to fill in those numbers and then work out with our Just very simple and easy, very not expensive calculator here. Okay, so P1 we know is 760 millimeters of mercury. So we write V2 equals multiplied by V1, which is 50 liters, all divided by P2, or the pressure. So there we have 1,500 millimeters of mercury. Now, in order to work this out, to make sure that we're headed in the right direction, we can also cross out our like terms. So prior to working it out, make sure that you're left with just what you should be solving for. So we know there's a millimeter of mercury on top and one on the bottom. And we're actually left here with the unit that we're needing to solve for. So let's go ahead and plug these in our calculator. And we get that 50 times 760 is going to give us 38,000. All divided by that 1,500. All right. Once again, going back to our trusty calculator, we're going to go ahead and do this one division problem, which is going to yield 25.3 liters. Always make sure to make note of what place your question or your test, exam, quiz, or worksheet is asking you to round to. And this here concludes Boyle's law.